Yeah, exactly. I have to have this cancel out by using the square root sign. Okay, so in order to write 3 as a square, you have to use a square root because they can then cancel. So what about 5 as a cube? So as a cube, you would have 3 of them. And so what will we have to do to cancel? Not square root, cube root. Now make sure your number 3 goes inside the check mark. Okay, often I see this. This is incorrect. Okay, wrong. We're going to see why today. Okay, that's wrong. Do not put the 3 outside. It must go inside. Raise it up. Okay. So if we're working backwards then, if we have 11 times 11, what does that equal? No. Well, but it equals square root 121, but let's simplify it. Equals simply 11. Because the index is a 2, we're looking for pairs, and then the digit of the pairs can come out. Okay? The digit of the pairs can come out. Now look at this. Here's a 3, so instead of pairs, what are we looking for? Triples. So here's a triple, and so the digit 9, or the value 9, can come out. So applying that, what's the next one in the pattern? Yeah, so we're looking now for 4s, and there's one group of 4, so 6 can come out. Okay. That's what today's lesson's all about, folks, right there. All we have to do now is figure out how to get these groups of 6, how to get those groups of 9. Okay? We're also going to use prime factors to help us. So, new skill. Write this in 3 different ways. Remember, multiplication can be done in any order. So that's different. It's the exact same. Okay, sometimes that messes you guys up. Another way would be 5 times 2 times 3. And another way would be 5 times 3 times 2. So let's not get too heebie-jeebied about the order of multiplication. Okay, all 3 equal the exact same value. All right. Good. Now, what we can also do is write this as an entire radical. Sorry, an entire radical. Do you guys know what that is? That's when we have this. Whoops. Usually we use the letter n square root x. Okay. Good. As a mixed radical, we usually have a letter out front. Notice how the n goes inside the check mark. Okay. So just to review our vocab, the n is the index, the x is the radicand. Okay. You must make sure that this line covers the number. For example, square root of 123 versus the square root of 12 times 3. Okay, big difference there. So make sure it covers the entire number. On your calculator, if the newer calculators, I find you should be very careful and use brackets. Okay, put an n bracket on there. Otherwise, you could be doing wrong. You could be telling your calculator to do the wrong math. Okay. Over on this side, nothing changes except for y. What do we call y? A number in front of an algebraic expression. Not constant. Close though. It starts with a C. The next letter is an O. Coefficient. Okay. So what this actually is y times y times n root x. Okay, it's a multiplication. In fact, when we're working today, we're always working with multiplications, right? Okay, so what we're going to do is we're just going to be simplifying. Your instruction will be to simplify. It doesn't mean to find an answer. It means to, right, evaluating is what we've usually been doing. We want to find an exact value, so not the decimal approximation. So this would be a non-calculator. But for big numbers, use a calculator to help you a little bit. Okay. We can take the entire radical and write it as a mixed. The index will tell us to look for groups of 3, or if it's a 7, then you're looking for groups of 7. Okay. What we're going to do is use prime factorization to help us. Now sometimes it's easy, right? Like if you have 144, the square root of 144 equals square root 12 times 12. No big deal, equals 12. But if you have some you don't know, then what we do is we prime factorize. Just divide this one by 2, divide by 2 again, divide by 2 again, divide by 2 again. What should we do with the 15? Divide by 5 or 3, whatever, okay? So what we have here is we can say that square root 240 equals square root 2 times 2 times 2 times 2 times 3 times 5. Okay. See how long that square root sign is? Make yours long. Okay. So what are we looking for again? What's the index telling us to look for? What is the index? Symmetry? Yeah. Yeah, it's in the check mark. And so what's our number right here? Symmetry? It's a trick question. Yeah, 2, right? We never write the 2. So we're looking for triples? Doubles, pairs. Okay? So there we go. We can underline that. So what we can do now is take these 2 digits outside and get 2 times 2 on the outside of the square root. On the inside, we have 3 times 5. They're lonely. They don't have any pairs. Boo-hoo, they're crying. So what's our final answer then? 2 times 2 equals 4. 4 root what? 15. So after we break it down, we then have to put it back together again. That's our answer, 4 root 15. Yep.
What is the difference between the 3 and you divide 15 and 5?
You mean right here?
Yeah.
Sure. 5 and 3, nothing changes, right? So you can choose, right? You don't have to do exactly what I do. You do have the option. You could have done that earlier too if you wanted. You could have started with the 5. Okay. Any questions? Okay, try the next one. 248. Sorry, not 248. 48. I want you to do that right now. See what you can do. Go. So, how many people got 4 root 3? Hands up. Awesome. Okay. Any questions for what I did? Yep, Carson?
So the following we don't divide the 2 by 2 again, just
Over right here, you mean?
no,
Oh, no, you wouldn't, because you get 2 and a 1. I mean, you could if you wanted. It wouldn't really change too much. Okay? I know why you're doing that, but yeah, it doesn't matter, Carson. Any other questions? Because I'm at prime, that's why I didn't. Okay. All right. Now, something to note is I don't really have to rewrite it, right? Once I've done this, I can start looking for pairs here. You got to be careful with it, though. right? Be careful. Here I go, oh, there's a 2 I can take out, and there's a pair, and what's left over? My 3. And so just from doing the work that way, I don't have to rewrite. I don't mind if you do that, okay? And then you can say, oh, 2 times 2 is 4, square root 3, that's remaining. Okay, so different ways of showing your work. Now, in the textbook, what you're going to see is you might see this. You might say, oh, they went and did square root 48 equals, 16 times 3. Okay, that equals square root 16 times square root 3. That's totally all right to do. And then you say that equals 4 times 3, 4 root 3. So there's different ways of doing it as well. This one I find is harder because sometimes, like 16, how did I get that? You got to really guess and check. That's why the prime factorization method is foolproof. But I just want to show you, you're welcome to do that, right? 16 root 3, square root them both. Okay, different ways, different things. Okay, let's do the next one now. So now we're starting with a number out front. Nothing really changes. You take 32 and do your prime factorization, please. Now what I like to do is I like to take this 3 and write it up front at the beginning so I don't forget about it. Now what can you take out? Max, what can you take out? Yeah, 2 times 2. So what you're doing is multiplying by the number that's already there. So the 3 in front, you're just multiplying by it. And what's remaining? Yeah, there's 1 left over 2. So you got to be careful you don't forget about the leftover stuff. Sometimes you'll see a perfect square and a perfect cube, but not all the time. So what's our final answer then? 3 root 32 equals, what do we get up front? It's times 2, 12. Okay, so 2 times 3 times 2 is 12, and root 2 is left over. That's our answer, 12 root 2. Not bad? Not bad? Okay, try the next one, number 4. Go. Well, this one's a little funky, isn't it? I get a 2, 3, and a 7. Something like that. Order doesn't matter. So this equals square root 2 times 3 times 7. What do you guys think we can do now? Any ideas? Jason, what do you think? Can we take anything out? Are there any pairs? Zach, any pairs? None. So what do we got to do? We have to say this equals square root 42. Can't simplify it. That's as simple as it gets. So you will see that maybe once or twice, right? Just to make sure you know what you're doing. If you can't take anything out, you just write it as it is. If you leave it blank, what happens? Mark it wrong. Okay, you have to say this equals 42. You have to say that's as simple as you can get. Okay, you can't simplify it anymore. All right, good. Number 5, go for it. Start dividing by 2. Use your calculator to help if you want, because this one's a bit bigger. The other questions before this are most likely non-calc, okay? This one equals 16. So this number is a perfect square, 16 times 16. So you'll see that once in a while too. You will see some perfect squares. Okay, how you guys doing? Thumbs up, down, in the middle? Show me. Everyone show me. Okay. Awesome, good. Okay, next one, another little bit different as well. So instead of pairs, what are we looking for? Triples. Okay, go ahead and try this one. Okay. Anthony, what can we take out? Good, so we can take out the value or a single digit 2. What's left behind? 3. So what we say is 2 cube root 3. Okay? 2 cube root 3. That's how we say that. Now, I'm going to highlight why you guys are all going to get this wrong on the quiz. Because you're going to forget about that 3 right there. Okay? Don't forget about your index. Make sure you write it in the correct spot as well. That's why most of you will probably get that question wrong on your quiz. Okay? Because you're going too fast and forget about it. Any questions? Okay, turn it over. You guys seem to be doing pretty good. So let's skip the first 2. Okay, that's just a little more work. Now, those will be calculator questions. Okay, we wouldn't put big numbers like that in the non-calc. We might, but probably not likely. Let's do number 9, please. Go. Probably start by dividing by 5, because I'm not sure. Okay. Here the index is telling us to look for 4s. And here's a single group. So, Justin, what's the answer? This question 9. Yeah. 3. Oh, you haven't done it? You're working the other ones? Robert, you want to give it a shot?
3, 4, 2, 5.
Perfect. Good job saying that. Well done. Okay, so 3 4th root 5. Okay. Make sure, again, you haven't forgotten about the 4 and you write in the correct spot. All right. Okay, so let's do this with letters. And this is getting up there, honors kind of bonus type work. But let's just kind of apply it and see what happens. It's hard to see it in this format. So what I want you to do is I want you to expand these guys. Okay. Then you're going to say, oh yeah, now I'm looking for groups of 3. I can see it. So go cube root. Instead of A, go A times A times A. Okay. Times B times B times B times B. And the same thing with the C's. How many will there be? 7. Six, 7. Looking for triples. So, triple, take out an A. Triple, take out a B. Triple, take out a C. Another triple, take out a C. Now I do have some remaining. Right, here's a B left over and a C left over. So on the outside, we have A times B times C times C. That's all that we could take out. And remaining is B times C. That would be full marks. What would be for full marks? Ishwan? Yeah, close. A, B, C, yeah, C squared. So you use your exponents. Cube root BC. Okay. So notice here, if you're just looking at this, you'll be looking for how many groups of 3 are in this exponent, how many groups of 3 are in this exponent, and how many groups of 3 are in the last exponent. Okay. And that would be the exponents when you take them out. So A exponent 1, B exponent 1, C exponent 2. Because in 7, there is 2 groups of 3. And 1 remaining. And the remaining 1 goes right here. We just never write it. Okay. Again, that's really pushing it. You should be able to get it, you know, but it's getting up there. All right. Any questions about that? Okay. We do see a few more of those when we get closer to review. Just kind of getting old school. Okay, so then we have to go the other direction. Now this is easy. Okay. So we have a mixed radical, like 3 root 2. We want to change it to an entire radical. So the index tells you how to do that. If it's a 3, you multiply the number you brought in 3 times, or 7 times. So we did that right at the beginning. Don't flip back, but I'll just show you. So if we have 3, that's square root 3. If we have 5, and it's a cube root, you got 3 of them. Okay? Then you just got to multiply it all together. So this is going to equal what? Square root 3 times 3 times 2. So to bring the 3 inside, you have to have 2 of them. Okay. Final answer then? $18. Yeah, you multiply them up. Okay. Do the next one. Go. Go on. Okay, so 2 times 2 is 4, times 2 is 8, times 5 is 40. So cube root 40. How many people got that? Hands up. Awesome. Last one, go ahead. Use your calculator for that if you will. I cheated with my work. You're welcome to cheat too. Okay. So for question number 3, 4th root of 768. Hands up if you got that. All right, perfect. Any questions? So what we're going to do then, without the use of the calculator, you want to estimate and arrange from least to greatest. Okay. So what we want to do is change to entire radicals first. Because if you have square root 14 and square root 15, which one's bigger? Yeah, the one with the bigger number. Now if you have square root 14 and cube root 10, do you know right away which one's bigger? No. Here you got to kind of find some approximate values. Okay, and that's what we did before. But if they're the exact same radicals, you'll know that one's larger because it's a bigger number. Index are the same. So right now I want you, for A, B, and C, just change these to entire radicals. Go. Again, it's no calculator. Put those things down. It says right at the front, no calculator. Okay, so 7 times 7 is 49. Times it by 2, double it, but then, okay. Okay, so I just showed you a little bit of math work, what I was thinking. Instead of going here, instead of going square root 16 times 6, which is a little bit harder, I just went 24 times 4, which is close to 100, right? Because it's like 25 times 4. Okay, so think about that when you're doing your work. Try and make it easy for yourself. Now, right away, I could put those in order. Which one's the smallest, A, B, or C? B. It's the smallest number. What's in the middle? A, then C. Okay, C is the highest. So that's good to know. Now, let's look at the other two. What do you think's higher, D or E?
E.
E? D. D or E? D or E? Well, let's just look at this. If we have the square root of 16 equals 4, I know that. But what about the cube root of 16? If we increase the index, we're now looking for a number that multiplies itself 3 times to equal 16. So instead of multiplying twice, it's got to be 3 times. That means it's got to be a smaller number. Okay? And I'll just show you on the calculator, because now you're thinking, oh, he doesn't know what he's talking about. Square root of 16 is 4. The cube root of 16 is 2.5. Right? So you got to get a smaller number. So right now, we know the order should be something like this. B, A, C. And then, don't write that down, please. Then E, then D. But we don't know if E should go in the front or the back. It's kind of like what we got to decide, right? So what we need is some values. Let's choose a couple values to work with. First of all, what are these ones really close to? 100. So let's just pick the 96, square root 96. Perfect square above is 100, which equals what? 10. What's a perfect square below? Well, below 10 has to be 9, which equals what? 81. So this is going to be approximately what value? You should be writing this down now, by the way. That's going to be approximately what? 9.8, 9.9, something like that, okay? It's going to be really close to 10. But what about the other one? What about the cube root of 10? Well, what's a perfect cube below 10? 1 times 1 times 1. That equals 1. So if this was 2, what would this number then be? 2 times 2 times 2, 8. Oh, is that going to work out? No. So what we actually have to do is then just simply move this one down below, right? So this should be the low value. Okay. And this one will be 3, which is cube root 27. So this thing is going to be approximately what? 2.1. It's going to be really close to 2. Okay, maybe 2.2. So what we have here, though, don't forget the beginning one. We have 2 times 2.1. Whereabouts is that going to be? 4. Right? 4 points, 4 point something. Okay. So we know that D, we have here, B is smaller than A, than C. Over here we know D and E, and so when we put these together, these ones are about 9.8, this one's about 4. Where should D and E go? Right at the beginning, because they're the smallest. So D, E, B, A, C. Least to greatest. Okay. And we actually call that ascending order. It's going up. Okay. Okay. Ascending order. D, E, B, A, C. Oh, I screwed that up, didn't I? You guys should have said something. I know I heard something. E is smaller. Okay. So it should go E, D, B, C. E, C. Okay.